Hi everybody, it's Mrs. T, Mrs. T's Chem Talk. I'm going to make a quick video on finding formulas from percent composition. So in case you don't know who I am, my name is Elizabeth Tominello. I'm a chemistry teacher at Calhoun High School in Merrick, New York. So when we see a problem like this where they give us percents and they want us to find an empirical formula, first of all, remember that an empirical formula is the reduced formula. It's the lowest whole number ratio. And remember that in any formula, the subscripts are mole ratios. So we already know something about moles. We know a lot about moles. So if we want to do mole ratios to get our subscripts and they're giving us percent by mass, the first thing that we're going to say is that, okay, if we have a 100-gram sample, that means that we have 38.76 grams of chlorine and 61.24 grams of oxygen. We know how to go from grams to moles. So that's all we're going to do here is just say, hey, these percents are out of 100. In a 100-gram sample, we will have this many grams of each element. So in order to get us to moles, remember, we're going to use our dimensional analysis here. We need to use the periodic table, we need to have a calculator, and we need to find the masses of each of these elements. So if you need to pause to get your calculator and to get your formula sheet to make sure you have the periodic table, you can always pause me, you can always rewind, you can always go back. So since we're in grams, remember that we're going to multiply by 1 mole by over the mass of 1 mole. For chlorine, it's 35.45. And for oxygen, it's 16.00. Remember, this doesn't have a subscript here. So since there's no subscript there, we're finding the mass of oxygen, not the mass of O2 like we do if we're talking about it as an element. So now, once I do these calculations, and you should be doing these calculations along with me, you shouldn't just be watching. When I do 38.76 divided by 35.45, I wind up with a number that's really long, and I'm not going to round it here. I'm going to keep a bunch of digits here because we want to make sure we don't round these numbers and then make it harder to find the ratio. For the oxygen, we wind up with this. And now remember, if we're looking for moles, this means that if I stop here, I wind up with Cl 1.09337 O 3.8275. And I've never seen a formula that looks like that. We need to get these to whole numbers. And in order to get to whole numbers, the next step is to divide by the smallest result of these calculations. So obviously for the Cl, we're going to get a 1, dividing by itself, by its own number. The 3.8275 divided by chlorine's number gives me a 3.5. So I have my formula, Cl1O3.5. And again, we don't use decimal numbers in formulas. So if you wind up with a decimal number, you're going to pick an integer, 2, 3, 4, 5, to multiply out by so that you wind up with 2 whole numbers. And when I have a 0.5, I'm going to multiply by 2. So my empirical formula is Cl2O7. And that's the final answer for this particular question. So now if they ask instead for not just the empirical formula, but also the molecular formula, the percents will lead us to that lowest whole number ratio empirical formula. They're going to give us a molecular mass or a range of molecular masses to use in step 2. So the first step is going to be to use the percents like we just did, right? And then step 2 is going to be to worry about the molecular mass, or not really worry, but to concern ourselves with the molecular mass. So we're going to do the same thing where we take our percentages and say, hey, if they give us a 100-gram sample, that would mean that we have the percentages, that we have these percentages translating directly to grams, because in a 100-gram sample, each of these percentages, when we add them up, we'll get to 100. Each of these percentages will be our grams of each present. So the first step is to convert each one to moles. So we're going to convert to moles, divide by the smallest result, and then if we need to, try that again, and then if we need to, multiply all the results by an integer to get a whole, or to get a set, to get whole numbers. These are our steps every time we start with percents. So I have 49.3 grams of carbon. Again, I'm going to multiply by 1 mole over the gram formula mass of carbon to get the carbon to moles. 6.9 grams of hydrogen, multiply by 1 mole over the gram formula mass of hydrogen. And for oxygen, I'm going to multiply again by 1 mole over the gram formula mass of oxygen, because the subscripts in formulas are mole ratios. If we're in percent, we change it to grams and we go to moles. I'll give you a second to do the math. You should be doing this along with me. If I go too fast, you should be pausing and catching up with the math. Just remember, we said that AP Chemistry is not a spectator sport. We want to make sure that we're doing this math along with me. We're going to keep the values kind of long. And again, I've never seen formulas with decimals, so these are not whole number ratios. We are going to divide each result by the smallest one to get to a whole number ratio. So oxygen subscript is a 1 right now. And I wind up with 1.4995, which I'm going to call 1.5, and 2.5. So I have C 1.5, H 2.5, O 1. And again, remember, we need to multiply out by some integer that is going to make all of these become whole numbers. And if I multiply by 2, I get C3, H5, O2. This is the empirical formula. If you want to convert the empirical formula into a molecular formula, we now have to take into account the overall mass. So C3, H5, O2, if I look up the mass of that, C3 is 36.03, H5 is 5.04, and then the O2 is 32. When I add this up, the mass is 73.07 is the molar mass, or the molecular mass. So I have to look and see, okay, how many times does 73.07 have to be multiplied to get to that range? If I multiply by 2, that's only around 146. But if I multiply by 3, I wind up with 219.21, which fits nicely into that range. So since I have to multiply the mass by 3 to get to the molecular mass, I have to also multiply the formula by 3 to get to the molecular formula. And that means multiplying out all of these subscripts by a 3, and I wind up with C9H15O6, and that is now my molecular formula. So there was another step here where I had to take into account this mass. So that was our introduction to finding formulas from percent composition. Hopefully that helped. You can now work on those questions. If you have any questions for me and you're one of my students, feel free to reach out via Remind, and I will help you the best that I can. And happy studying.